actually am.
So before we get into the nitty gritty of this, which is going to take us a while, and this is quite a lot to learn, we're going to do a few definitions. So the first definition is a ligand. So just bear with me, because you've not heard of these terms before. A ligand is a molecule of iron that bonds to a metal.
Like a ligament.
So, what do we mean by that? It's a ligand is a molecule of iron that bonds to a metal by a coordinate bond. What's another name for a coordinate bond?
Dative.
Dative bond, yeah. So a ligand must have a lone pair of electrons. So it's got to have 2 electrons that it can donate to a transition metal ion, like so. So, what is when you talk about complex, what is a complex? So, when we talk about a complex, it's a metal ion with coordinately bonded ligands. So, it's a metal ion with coordinately bonded ligands. The last one is a coordination number. The coordination number is the number of bonds that the ligands form to the metal ion. So that's basically the number of coordinate bonds you've got. So number of coordinate bonds, so number of coordinate bonds from the ligands to metal ions. So you need to know those 3 definitions.
I'm definitely not going to work.
So we're going to go through, there's different types of ligands. The ligands are classified by the number of lone pairs they have, so the number of dative covalent bonds that they can do. The simplest ones, so they've all got to have lone pairs on them. Monodentate ligands have 1 lone pair on them that they can use to form a dative covalent bond or coordinate. So, for example, e.g., a simple one would be the chloride ion. The chloride ion, Cl minus, obviously he's got a lone pair that he could form a dative covalent bond with. Another common one, as a molecule, is going to be water. Water, we know, on the O has got, he's actually got 2 lone pairs, but he can only ever, if they're on the same atom, he can only ever use 1 to form the coordinate. So if I'm going to put a little arrow next to the lone pair, remember an arrow shows a coordinate bond. Okay. An arrow shows a coordinate. Another common one is ammonia that we'll be using. Ammonia NH3. He's got a lone pair of electrons on the nitrogen that he can use to form a coordinate bond with. Another interesting one is actually the cyanide ion.
Oh.
What do you use it for? Isn't cyanide poison?
It is, yeah. Cyanide ion there. And another, the final one that we'll do is the hydroxide ion. OH minus, he's got a lone pair of electrons on the oxygen. Oh, the cyanide there. Okay. So just be clear that even though I can have 2 lone pairs on one atom, I can only have 1 coordinate bond per atom. So these are all monodentate ligands because they all have only one lone pair that they can use to form a coordinate bond. Water's got 2 lone pairs, but you can only use one to form a...
Is that why the case with everything?
Because if I'm a metal ion,
No.
well, it would mean, it would mean, say it's copper, it would mean if I've got water like that, it would mean the other lone pair would have to be used in some sort of double bond way, and you don't get that going on. So don't worry. I mean, it is. If you wanted to go on and do chemistry as a degree, then you could talk about that.
Yeah,
if you
so
like,
we'll do
but
that.
let's not go there.